Okay, now that I've resized that one, we are done with step 2, and we're going to move on to step 3. Step 3 does kind of the same process, but this time we have that the height is not given to. We're going to be graphing these energies versus time instead of versus height on the x-axis. So what that means is we're going to need to actually do some calculations for what the height is at different times. We'll also need to do some calculations for what the velocity is at different times. So we're going to go through that process. If you're feeling pretty confident and given those two reminders that are posted right there, you feel like you're able to do the calculation, then go for it. Do it. Otherwise, we're going to walk you through kind of what to do. One thing to note is we've got our initial height and our initial velocity kind of provided for you. Okay, so first things first, let's figure out what the velocity of our object is at different times. So what we're imagining here is an object that was fired straight up. It had an initial velocity of 10. It is being pulled down by gravity, which we're assuming is negative 10. And we are looking at what is its velocity each moment in time, as well as what is its height each moment in time. We've got a nice reminder here for velocity that v equals v naught plus a times t. Another way to view that, and I'll actually update this reminder for the future, is that v equals u plus at. That reminder must have been written when we used a slightly different notation. Sometimes people use v naught, sometimes people use u. Don't worry about it. So we've got, remember that v equals u plus a times t. And here we've got, remember that d equals 1/2 at squared plus u times t. So that's the u instead of v naught times t. So we'll use those reminders to do our calculations. So for our first one, we've got that velocity for something kind of in free fall that's been launched up is going to be equal to our initial velocity, which was 10. So I'm just going to type that in as a number. And then we add to that, so plus, I'll say shift and then the plus sign, plus, so it's v equals u, that's our u was 10, and then plus a times t. So I'll say plus, and then I'll go over here and select our acceleration, and then I'll say times, and I'll go over here and select our time, and hit enter, and we'll do it again. Equals, I'll go ahead and type in 10 because that was our initial velocity, and then I will say plus, and then I will go over here and I will say the acceleration, and I'll say times, and then I'll say time. And at this point, you can highlight these two cells. Don't highlight this top one because it had a different formula in it. And you can go ahead and fill down, or you can keep doing it yourself. So you can say equals 10 plus, you click on the acceleration, click on the acceleration, and then I say times, and then I click on time. And I do it again and again and again until I've filled all the way down, or you can highlight and drag and fill down. Not too far though. Cool. So we have that by the time it kind of lands again, it looks like it is reaching a same velocity it started with, just in opposite direction. So it looks like it takes 2 seconds for it to kind of go up and come back down. Next, we're going to do height. Remember that our height is going to be equal to 1/2 times at squared, but we also have to add in the ut. I think in your formula book, it's actually written as 1/2 ut plus 1/2 at squared. So I'll rewrite this version to match yours, and I'll do the same on yours. Sorry about those updates live. So let's go ahead and type that one in. Our initial height is going to be 0, so we're going to start here, and we say equals, and we say our initial velocity, which was 10. We say times, we click on time, and then we say plus 0.5, because that's what 1/2 is, times, and then we say acceleration, that's right there, and then we say times, and we click on time, and we square it. So I'll click on that A22, and I will square it. I'll do it again. Equals 10 times our time, that's the ut, plus 0.5 times the acceleration times our time, and then squared. Hit enter. Now I can keep typing that in over and over, or at this point I can highlight those two cells and I can fill down. Not that far. There we go. So I'll fill down. And so now we have our heights, and here we can see the height returns back to 0. So cool, that looks like it works out. Now that we have those two sets of data, we can do our calculations just like we did before. So now that we have those two sets of data, we can do our calculations just like we did before. So for gravitational potential energy, I'm going to say equals its mass times gravity times height. So I'll go ahead and click mass, say times, click in acceleration due to gravity, click times, and then click our height, and we can see that it will do that calculation based on multiplying those things. I can do that again, equals, I will say our mass, then I will say times our acceleration, which is gravity, times, and then our height, which is 0.95, and we get that. Here we have that it is negative because the acceleration is negative. So one thing we can do is, instead of using that cell for the acceleration, if we don't want it to come out negative, which is a little bit funky, we'll actually go ahead and just type in 9.8. Or 10 is really what we're using. And this way we're kind of ignoring that sign there. There's other ways to do it, but this is probably the easiest. So we'll say equals, we have the mass times gravity, which we'll say is 10, times our height of 0.95, hit enter, do it again, equals, we click on our mass, we say times our value of gravity, which is 10, and then we say times our height, which is right there, and we say equals, and we get that calculation, and that will be a little bit cleaner than having all those negative numbers, and we'll keep our graph looking proper. At this point, we filled in enough that we can fill down our formula. Notice that it reaches its maximum GPE right in the middle and then comes back down to 0 when we said its height was 0, so that kind of makes sense. We're going to go through the same process as we did above for our kinetic energy. So we'll say equals 0.5 times our mass times our velocity squared. So it's 1/2 times mass times velocity squared. Cool. Notice that that kinetic energy equals our max GPE over here. So that, again, process makes sense or calculates out. We'll say equals 0.5 times our mass times our velocity, and then we will square it. And then at this point, we are able to fill down. So you can keep doing that over and over and over again, or you can fill down, and we've got that. Now, if you remember from before, our total energy is simply the column B plus column C. Alternatively, you could use the sum function if you want to try that one. So we say equals B21 plus C21. Cool. We do that again. Equals our column B plus our column C. Cool. And then we go ahead and fill down. And what we can see is that the total energy stays the same. Now, this would be a good time to go back and take a look at our total energy from before, and we have that it effectively is staying the same, minus a little bit of rounding error due to not having velocities go out to probably like a very tremendous number of decimals. But if you look at all those, they're basically staying the same, and again, that's just due to our rounding error here. All right, so next, we're going to go back down. This time it says make a scatter plot of the energy time graph with the 3 energies. So I'm going to go ahead and highlight our data here. I'm going to go to Insert. I will go to Charts, and it's going to auto do that, but we need to double check that the setup was done correctly. So I'm going to scroll back, and it looks like it wanted to do a line chart for me. I want it to do scatter plot. So it often likes to auto suggest a line. We always want scatter plot so we can see our individual data points, and then we go back to customize and we actually add in our trend lines. So to add in trend lines, we're going to go to add in trend line. Looks like it didn't recognize those trend lines very well, so I think we have to do this individually for each one. So for gravitational potential energy, this does not look linear, so I'm maybe going to say it looks like a parabola. And so if I'm trying to do a parabola, what I'll do is say, instead of linear, we'll try polynomial. So we do polynomial, and we see, oh look, yeah, that seems to work out properly. And then we can, and polynomial, if it's a level 2 polynomial, that's basically quadratic is what that is. And so then we can go back and we can say, okay, now let's try kinetic energy. And we go back down and we say add trend line. And this time what we're doing is saying, okay, instead of linear, let's try polynomial. Cool. And so we've got a polynomial trend line. Now that top one, that total energy, in this case is still going to be constant, and so as a result, when we get to total energy, we can leave it as linear, and that works out. Awesome. Now for all of those, we want to go ahead and show equations, so I'll say apply to all series. I will say label, use equation, and we get all of our equations. And we can see that this very tiny number, that's what that e to the negative 14 means. We basically got 0 equals 500x plus negative 250 times x squared. And that is for our gravitational potential energy. We can probably track that out to being linked to something. Here for the kinetic energy, we have that it looks quadratic or follows a parabolic form, and then total energy is staying constant. I'm going to go ahead and change our title here to be a little bit more representative, GP, KE, and total energy for versus time. Cool. Going to go ahead and drag that down. Drag that down a little bit further so that's in the proper spot, and then resize it as needed so that it fits our space. Cool. Seems to work all right. All right, so in this one, we are going to go ahead and create a stacked bar chart showing GPE and KE for the time of 0 to 2 seconds. What this should look like is your energy Lego graphs that we did. Notice it says don't use total energy, so let's go ahead and do this. For this one, let's go ahead and highlight from 0 to 2 seconds. We're not doing total energy. We'll go ahead and go to Insert, Chart, and instead of doing a scatter plot, it's trying to learn like, oh, you seem to like scatter plots. We're actually going to change it, and this time we are going to go down here and we'll look in the column, and we want the one that's stacked, so a stacked column chart like this. So let's go ahead and do that. So once we do that, what we notice is a nice little trend. We have that our kinetic energy, gravitational potential energy is increasing kind of quadratically versus time. We also have that our kinetic energy is kind of decreasing in a parabola or quadratically over time, and then both flip and they start to do the opposite. So that is our graph for that one. Pretty simple and straightforward once you have all that data. You can mess around with the titles to get that a little bit more clear, but we now have our kinetic energy stacked column graph. Next, what you're going to do is write 3 trends that you see in the graphs and explain conservation of energy to a 6th grader. So what you'll do is you'll take a look at the graphs above, whether that is the stacked column graph that looks kind of like a Lego graph, or whether that's the other line graphs that we did above, or even the one way up top. And you just need to identify 3 trends or patterns. So maybe you notice that there is a linear relationship between GPE and height, as well as kinetic energy and height. But maybe you notice that the relationship between GPE or kinetic energy and time is not linear. It's a quadratic relationship. Those are the types of things we just want you to write. I've basically given you 4 right there, since you can talk about GPE and kinetic energy separately. So you find 3, write them down. Then you're going to go ahead and explain conservation of energy to a 6th grader, so kind of using what we've talked about or what we've learned in class and using the graphs above. And you would write your answer in here. The previous gibberish was from the previous video or a video attempt where I was kind of showing you what to do. But one thing to note is that as you are writing, you need to make sure that you hit the return or enter button when you are done writing so that it saves what's in your cell. If you don't do that, then sometimes it deletes it, and then it's really sad because people end up typing and losing like whole paragraphs. If you have too much trouble with it, just write it on paper, and that is fine. That's it for this one. A little bit of a shorter video. Might actually get lumped in with the previous video we will see in post editing. If you have any questions, see your teacher or rewatch one of the videos.